Hello everyone, we can start with question number 1. So it says that it is found that if a neutron suffers an elastic collinear collision with deuterium at rest, fractional loss of energy is PD, that we will assume, while for the similar collision with carbon nucleus at rest, fractional loss of the energy is PC. So we have to find the value of PD and PC respectively. So first we will see by the diagram that we will have a mass 1 and another mass 2m which is at rest. First initial velocity will be v0, then v1 and v2 respectively. So according to the question given, we will form an equation which is mv1 plus mv2 2mv2 equals to mv0. As we know, k equals to mv, so we are finding the kinetic energy. So v1 plus 2v2 equals to v0 after cancelling out the m on both sides. This will be our first equation. By another formula, E equals to v2 minus v1 upon v0 equals to 1. So we know that v2 minus v equals to v0 after sending v0 to other side. On solving, we will get v2 equals to 2v0 by 3 and v1 equals to v0 by 3. So final kinetic energy of the neutron will be half mv1 square plus half mv0 by 3 whole square. So that will give the final answer to 1 by 9 half mv0 square. Then we have to find the loss. The loss of the kinetic energy equals to 8 by 9 half mv0 square. Fractional loss will be PD equals to 8 by 9, which is 0.89. Similarly, collision between neutron and carbon atom we have to find. So mv1 plus 12 mv2, 12 is the mass, equals to mv0. v1 plus 12 mv2 equals to v0. So this we already know in the previous solution. On solving, we will find that v1 equals to 11 v0 by 13, and final kinetic energy will be half m 11 v0 by 13 whole square equals to 121 upon 169. So loss of kinetic energy will be 0.28. Thank you.